you're like 98% of the way to OpenID Connect. It's just a matter of getting the bits in the right place at that point. Because all of the processing for a basic OpenID Connect authentication transaction happens over OAuth 2 and is communicated using Jose. So how does that work? The key thing to remember with Connect and the pattern of Connect is there's more space kind of in the dead corner back here if you'd like. Probably be easier. There's really kind of a paucity of rooms this morning. Sorry about all this. So the real key thing to remember with OpenID Connect and most other OAuth-based authentication protocols is that because at its core OAuth is a delegation protocol, it is a protocol that allows a resource owner, usually an end user, to delegate authorized access to something. What's actually happening in all of these identity protocols that are built on top of OAuth 2 is that the user is delegating access to their identity. Now, what does this look like? In a normal federated identity setup, you have an identity provider, right? And you have a relying party. And the whole goal of a federated identity protocol is to get an identity that's provable up here, that to be verified and trusted by the relying party. That, at the end of the day, is what you're trying to do, because you have a user that's over here. You need to get them to give you something from up here that they can show you down here that proves who they are. So how does this map to the OAuth diagrams? So with OAuth hats, the identity provider is actually the OAuth authorization server. And that makes sense, right? So there's a primary logon over here, and this is where the user's consent is collected and all of this stuff. Most people seem to get that pretty reasonably. But where people start getting tripped up, I find, is what is the relying party? A lot of people will look at this and say the relying party is the OAuth protected resource, because this is what we're trying to have you log into. So this is fundamentally what we're trying to protect, right? Well, in fact, that's actually not the case. The relying party in all of these different protocols, OpenID Connect particularly, is the OAuth client. So where's the protected resource? It's actually part of the identity provider. Because here's what happens. The user shows up at the relying party and they're unauthenticated. The relying party needs to be able to tell the user, go to an identity provider and give me something that proves who you are. So that type of, redirect you somewhere else, go get something, that fits very, very nicely with OAuth, because in OAuth, you traditionally start at the client, get redirected to the authorization server, and come back from the authorization server with a thing that you can use for stuff. It turns out, in OpenID Connect, by adding a few things on top of OAuth 2, you actually end up coming back with something that can be used to prove your identity. And so the protected resource that's defined by OpenID Connect is an identity API. All right? Now, there's a couple of different ways that you could do this. Most of them are wrong. A very naive way to look at this, and so this is actually feeding into a document that Hannes and I and others in the OAuth work group are working on right now. A very naive way to look at this is to say, well, I got an access token, and I'm going to call an API up at the identity provider, and that's going to call back, and that's going to tell me who authorized the access token, and therefore will tell me who is actually logged in. The problem here is that using an access token to call an identity API will probably tell you who authorized it, but it ain't going to tell you jack about whether or not they're still there, how they logged in, whether it was actually issued to you, or all of this kind of authentication context kind of stuff that you need in order for an actual authentication and identity API to work. So OpenID Connect solves this by having a secondary token come across. So we're used to having the access token come across from the authorization server back to the relying party. And that access token still exists in OpenID Connect. It is fundamentally OAuth 2. And this is important because that access token can be used for not only the protected resource that's defined by OpenID Connect, but also other protected resources that might not be defined by OpenID Connect. So this could be a calendaring system, a messaging stream, all kinds of other just normal vanilla OAuth 2 stuff, right? So OpenID Connect, in order to actually convey that authentication context information, you get a second thing, you get an ID token back from your request. So how do you request that you want an ID token as part of the request? Well, OAuth has a mechanism already built into it that says, here's the kind of thing that I want access to from the authorization server, and that's scopes. So OpenID Connect defines a core set of scopes, most important of which is the, surprise, OpenID scope. So what happens when you're talking to an OpenID Connect server, you make an OAuth transaction and you ask for the OpenID scope for your client. What that does is that switches on effectively OpenID Connect's processing inside the server and tells it generate and issue an ID token along with the access token. Now I'll take a pause here to point out that the ID token in the most sensible use cases, there's all kinds of fun optionality, but in the most sensible and basic use cases always comes back right alongside the access token, which means that if you're doing an authorization code flow, then you bounce the user out through a browser, you get back the auth code, trade the auth code, and you get the access token and the ID token right next to each other. If you're doing an implicit flow, say you've got a JavaScript client, and by the way, if you're doing an implicit flow and you don't have a JavaScript client, you're doing it wrong, stop right now. And but if you've got a JavaScript client, then you're going to get these side by side as part of the URL hash on the callback. So what this means is that you now have two tokens in the system, and the important thing here is they have different audiences. This is why there are two parallel to each other. The access token, its audience, is all of the protected resources that are all out here, including the one back at the identity provider, which will tell you all of the profile information about the user, what to call them, their email address, and all of that other fun stuff. Profile information and identity attribute bundles, very important when you're building a sign-in protocol like this because nobody wants to be called user 34567, right? We all like to have names, and services like to get our email addresses so they can send us amazing offers. And that's what this protected resource called the user info endpoint, by the way. That's what this protected resource defines. However, that doesn't, like we said before, tell you the authentication context, because the access token that's coming back isn't really meant for the client. In OAuth, the access token is defined as opaque to the client, meaning as far as the client's concerned, it could be absolutely anything. However, we need to, in order to communicate the authentication context, have something that the ID provider sends to the relying party directly, hopefully, so that we don't have, more round trips and more man-in-the-middle opportunities and other fun stuff, other injection opportunities. Something sent directly to the client that the client can parse and understand that says, here's what's going on. And OpenID Connect could have done could have done it a couple of ways. One, and this was debated early on, we could have just defined the access token shall be this structure that the client must understand. But that breaks plain OAuth, because now the token is no longer opaque to the client. The client has to know what's going on in it, and it means you couldn't as easily run it side by side with an existing OAuth infrastructure. So what we chose to do instead was to have a parallel token, and this token, the ID token, is not opaque to the client.
Yeah, so first of all, can you actually write visible what the audiences of the different tokens are?
Sure. So the access token, the audience is for protected resources.
But is that like any? It's a star, kind of a wild card that matches any.
Anybody but the client.
But if even the client can take the role of a protected resource, this is obvious, right? So is there like really any restriction at all?
That's not true. That's not true. Because depending on how you actually design your access tokens themselves could have audience restrictions. It's just the client doesn't know about it, because it doesn't need to know about it. And it's not so much an audience restriction as much as it is the intended audience. So I could have an access token that is just a hex blob that absolutely nobody understands except these guys up here because they happen to be in the same box and they can go look it up in the database and get all the information.
So the protected resource 2, the number 2.
Oh, sure, no problem.
So the protected resource number 2 has some out-of-band way of actually checking that the access token is valid.
Any protected resource needs to have a mechanism for checking that an access token is valid. That is just
but
vanilla.
That's not specified in the OAuth, or?
No, it's actually, there are a number of popular strategies for doing this, and the 3 biggest ones are 1, look it up in the same database because you're in the same box.
So
that is far and away.
Check, okay?
Yeah, it's so some just out-of-band database lookup kind of thing. Far and away the most popular because a lot of cases the OAuth authorization server and protected resource are bundled very tightly together in a lot of cases. Second way when you start to distribute these things is to actually pack information into the token itself. The client's not intended to read it.
But
so
the PR2 knows the structure.
But the PR2 knows the structure, it knows how to look at it, it knows how to check signatures or decrypt it, or any number of things in order to figure out that the token is still good and what it's good for and who it was issued to and all of that other good stuff. The third way is to convey that same set of information, but by reference of the token. And what that means is that when protected resource 2 gets the token, it can make a call through something called token introspection. So it calls back with a simple web call back to the authorization server and says, I have a token, I need an adult, what is it good for? And that comes back in the introspection specification as just a plain JSON object that has all that information.
Okay, and now the client,
yeah.
relying party client, essentially he doesn't really know what the audience restriction or the authorization token, sorry,
right.
AT, he doesn't know what the audience restriction is. So he might send it to a protected resource that's not actually in the audience.
Yes, yes, he could. And that's the confused client problem in OAuth. And some of the proof of possession work that is happening in the OAuth working group is looking to actually fix some of that. But what a lot of people do is that they will build into the token metadata, either in the token itself or in the the introspection callback, an audience identifier of some type, so that when a protected resource gets a token that's not meant for it, then it throws it out. So what's interesting about that question, though, is that the exact same mechanisms are in place for the ID token, which come directly to the client, right? Because now the client gets this token, and OpenID Connect has defined it very specifically. It is a JWT, a JSON Web Token. So that is JSON Web Token, right? This ID token is a JSON Web Token. It has been signed by the identity provider. And there are mechanisms that are defined where you can discover the keys and all of that stuff for the IDP in order to check this signature. Not only has it been signed, but the structure of the body of the ID token is defined in such a way that it tells you who it was issued to, who authorized it, effectively, who issued it, when it was issued, when it expires. All of that stuff is prescribed by the OpenID Connect specification. So this means that if you have an OAuth client and you want to make it into an OpenID Connect client, here's basically what you do. You make a plain, regular old OAuth call, and you ask for a set of special scopes. When your response comes back through either the auth code or implicit mechanism, when the response comes back, you look for a second token. You'll still get your access token, but you'll look for a second token called the ID token. You take that ID token and using the Jose specifications, you parse it. You check the signature and you check the claims that are inside of that. Because as the client, it is your responsibility when this ID token comes back to make sense of it. Now, one of the key things about the claim set of that ID token, it is a JSON object, right? There are 2 very important claims, the issuer and the subject. And they're all 3-letter, almost inscrutable things because reasons. The issuer is a URL identifier of your identity provider. So this is, as a URI, it's a globally unique identifier that, you know, points to a specific server on the internet someplace, right? The subject is guaranteed to be unique for the particular user that you are talking to right now in the context of that identity provider.
Which is the issuer.
Which is the issuer.
So the two together will always provide a globally unique individual.
Exactly.
Okay.
Exactly.
And one of them will not, by definition.
Precisely. One of them alone will.
The subject will not.
The subject will certainly not. This is how we can get around the problem of username reuse and other stuff like that. And the subject in many cases isn't actually even a human readable username.
So one of the important differences from the previous generation of identity protocols was that we actually enforce uniqueness of the issuer. Mm-hmm. Entity IDs are not unique, which means that you again need a combination of subject, issuer, and some kind of key which is referenced through some other mechanism.
Well, entity IDs are usually, not by spec, but usually they are still URL based, so the uniqueness
depends on the environment, as you well know.
Well, so let me give an example.
I run into duplicate ones all the time, and even RNE federations have had that problem. So they're not, there's no unique.
I mean, there's of course an engineered duplicate situation when you want them to actually be logically the same, even if they are physical.
So the fact that they're allowed to be the same is the problem.
No.
Correct. So I'm making a statement as a question here.
Please.
So as an issuer, if I'm the IDP, it is my responsibility to guarantee that the subject is unique for me.
Mm-hmm. Yes.
For example, if I'm an IDP and I have 5 LDAP stores that are hanging off me, mm-hmm. I have not, and we'll just say I have not resolved that they don't have duplicate CNs or however you want to put it.
Right.
It is my responsibility then to, for example, create the subject name to include my LDAP source, mm-hmm. and my unique identity within that LDAP source, so the subject is unique for me as an issuer.
Absolutely.
That is a requirement of the spec.
Yes. Yes, and it's also.
Sorry to be so, but
no,
that's always been an issue before.
That's a fantastic
We're very
question.
specific about that.
Right.
Okay. That the subject must be non-reassignable, etc.
Right.
So there were some other
constraints
around that.
So
I was
a
actually just going
valid
to say
definition of a subject would be, and I'm going to throw it back to LDAP, would be a GUID and the LDAP source.
Yeah, that's a good way to
Because
look at
those are, most would call them unreassignable.
It's not required in your domain.
It's statistically possible, but I'll be dead before it happens.
But you can arbitrarily distinguish, say, the LDAP sources, right? You don't.
Right.
I can define the LDAP
There's no
source.
semantic significance to the LDAP source.
Right.
It's a string
except inside your domain.
Right. They should.
Right.
The relying party should not be attempting to parse out the subject to figure out what
And
LDAP.
that's what it
Yeah.
now means. The subject is not may not be a useful object for the relying party.
It's an opaque identifier string. Yeah,
That's non-reassignable in the context of the issuer.
Right, exactly.
Okay.
So if I'm the IDP, this identifier is this identifier only ever coming back to me when you're asking for then that following transaction about the claims? Or should I be giving a different subject to different relying parties so people can't correlate activity?
Great question. So the subject is generally not actually coming back to you directly. So because you don't have to put it into the access token, you do need to be able to resolve it so that you give the right claims when somebody calls a user info endpoint, because one of the claims, the required claim from the user info endpoint is subject. So you need to be able to make that mapping. However, that doesn't mean that it's necessarily coming back to you directly to look up. To your question of the per provider identifier, you can actually do that optionally inside of OpenID Connect. And so there's nothing that requires you to give the same subject to the same person every time. And there's,
so if you want to do pairwise pseudonym, you can.
What?
If you want to do pairwise pseudonym, you can.
Yes, yes, exactly, exactly.
So when you say person, do you mean the authenticating person, or do you mean the same identifier to the different resource? I authenticate for this service over here, I get one identifier. I authenticate through the same IDP to a different resource, I get a different identifier.
Yes, yes,
Okay.
that. Yeah, so a
So the subject
person
includes
defined as
We
back.
need to differentiate between client and resource.
Well,
So a
that's-
different identifier for
Yes,
the
sir.
client.
Yes.
So-
Right.
That's-
Right.
So-
Going back here, the relying party is the client and not the protected
So
resource.
there's another out of scope for OpenID Connect sort of notion. If your authorization server has multiple resources and you don't want the subjects to be correlated between those resource servers, then you could do pairwise identifiers inside of the access tokens or invent some other thing, but that's outside of the scope of Connect.
Yeah, that's just odd.
The subject.
But the-
Not always
People do lots of
guaranteed to be the same. So that's
So-
sort of, I understand what he was talking about, but what about for the same resource?
For the same resource, for the same client
Yeah.
and the same person, you're supposed to get the same subject identifier because otherwise it's going to act like a new account every
You're gonna
time.
need to use it as a key, so, yeah.
Right, exactly. And going
That's
back to
not
what...
that's not reassignable. So for example, using an email for the subject is probably a bad practice because
Yes.
it could be reassignable when Lloyd's fired and another Lloyd
We
is hired.
strongly
Right.
discourage
Right. There is a paragraph that
Sorry
I...
for my question, because I've read it in there, I'm thinking, are you guys really serious? And it sounds like
Absolutely.
the answer is yes.
So there's a paragraph in the section on the different claims that you can get back that says very emphatically, or I tried to be very, very emphatic when I
No,
wrote it.
the document's
Use
very
the
emphatic. I'm just
subject
trying to
and
believe it.
nothing else. So what you ultimately do, going back to what Lloyd was saying earlier, is you create a tuple in your data store of the issuer and subject. Combine those in whatever unique hashing mechanism you want to use in order to do that. So that when that issuer and subject pair comes back to you, then you can map that to whatever user object thing that you have inside your relying party, and you know that it's the same person. If they get a different per provider identifier, say your IDP's on crack and it's spitting out random subjects every time for anonymous accounts, it's going to look like a different user, and there'll be no way to correlate that. And there's nothing the relying party can do to actually control that because it's all the identity provider, as it should be.
Yeah, so essentially spitting out different every time is the temporary identifier idea.
Yeah.
But essentially in that case, for example, then your identity token might not include anything to personally identify you, but it could include something to say that you're over 18 or whatever.
Right, so the ID token doesn't, in most cases, actually contain extra claims about you. Most of those claims about the user themselves are stored back at the user info endpoint. So this is another thing that I think trips up people a lot, and it's actually fairly straightforward when you parse it out.
Issuer and subject,
When you
more.
when you parse it out, is that the ID token, because its audience is directly the client, and it's really meant to convey sort of the authentication event information. So who was there, when did they log in with the IDP, information like that. It can contain, because it's a JSON object, it can contain all sorts of crazy things. Google insists on cramming the email address into the ID token every time, because Google. However, profile information, stuff that doesn't really change a lot over time, goes back in the user info endpoint, because that's something that's more stable and dereferenceable when needed by the relying party. Because one of the things that we found, that a lot of people found really, with OpenID 2, was that it was a real pain to have to ask for all of the profile information on every single transaction in case it's a new user I haven't seen before. So instead, with OpenID Connect, you get the authentication information every time, because that's what you want. You know, did somebody log in? Who was it? And if I haven't heard of them, or if I haven't refreshed their information in a while, I can take that access token and go get their profile information and update my cache. Because let's face it, you're going to cache their profile information in some type of user object in a database somewhere, because that's what you do.
Unless you're using the temporary IDs, in which case you're not.
Well, you can cache it all you want, it just won't do you any good.
So is that communication part of OpenID's?
Yes.
OpenID Connect?
Yes, it is. So there, that is a mechanism called the user info endpoint. And that is actually just a plain OAuth transaction. So if we ignore the ID token for a second, we're just getting user profile information. what I'm really doing is I'm saying that there's a client here, and I want them to be able to read my profile, know what my email address is, know my name and my profile picture, and my mailing address, my phone number, and these are all split up into different OAuth scopes, by the way.